Hello and welcome to the Chemistry Academy. In this video we're going to cover atomic structure, which is relevant to National 5 Chemistry Unit 1. So if we get started, I've drawn an atom here and we're going to label the different parts of the atom's structure. So in the middle we have what's known as the nucleus. So the centre of the atom is known as the nucleus. And in the nucleus we have two of the three subatomic particles. So a subatomic particle is just a small part that makes up an atom. There are three of them: protons, electrons and neutrons. And the two that are inside the nucleus are the protons and the neutrons. The protons are the ones with the positive charge, and the ones with no charge are the neutrons. Okay. Things that you need to know about the subatomic particles are their names, where they are located, their charges and their masses. So we've labelled the names: protons, neutrons. The location is in the nucleus for the protons and the neutrons. The mass of a proton is 1 atomic mass unit. Atomic mass unit is just an arbitrary unit that the chemists have developed to compare masses of these tiny little particles that we actually can't weigh accurately. The mass of a neutron is also 1 atomic mass unit, so that makes it a bit easier to remember. Both of the particles in the nucleus have a mass unit of 1 each. And then the charge of a proton is positive 1. If you try and remember that the P for positive is the proton's charge. And then the neutron, as I said before, has no charge. So neut for neutral is what I want you to remember. So proton, positive, neutron, neutral. We then have our third and final subatomic particle, the electron. The electrons are here in these energy levels, or electron shells as we call them. So they orbit the outside of the nucleus, and these can be labelled as, like I said, energy levels or electron shells. Okay. And the electron has a mass of pretty much 0. It is so tiny, it doesn't really have a mass. So the words you'll often see in your SQA exam are that it's almost 0. That's how you spell almost, Kimberly. So almost 0, or negligible is the other word that you'll often see. And negligible just kind of means it's so small it's not really worth worrying about. And the charge of an electron is -1. So there's not a letter or part of the word that helps you remember the charge of an electron. So my advice would be to remember the charge of a proton and a neutron, and then the only charge that's left, which is negative, is then the charge of the electron. So your protons are positive, your neutrons are neutral, and your electrons therefore are negative. Again, with the masses, remember that the two subatomic particles that are in the nucleus both have a mass of 1. The electrons that orbit the nucleus have a mass of almost 0. They don't have a mass. So that's all the different parts and locations of an atom. Now, if we look at this atom specifically, every element has different types of atoms. So a hydrogen atom would look different to a helium atom. And that's what makes an element. It's a substance that's made up of only one type of atom. When we then join different types of atoms together, that's when we get a compound. Or if we have a mixture of different atoms not joined together, then we would class that as a mixture. So an element is a substance that contains only one type of atom. Every different type of atom will have a different structure, and this is where our atomic number comes in. So if you look at the periodic table, every single element has its own atomic number, element number if you like, and that number tells you how many protons will be in an atom of that element. So hydrogen is atomic number 1, element number 1. because its atomic number is 1, that tells us that there would be 1 proton in its nucleus. Okay. This picture I've drawn here, if we count how many protons are in it, there's 3 protons in here, which means this must be element that has atomic number 3, which means it is an element of lithium, because lithium is atomic number 3. The mass number then is made up of the number of protons plus the number of neutrons. So looking at my picture, I have 3 protons, which each have a mass of 1, and 4 neutrons, which also each have a mass of 1. So 3 plus 4 gives us 7. And what we can do is write this information as something called nuclide notation. And nuclide notation is a shorthand way of writing down the element symbol, atomic number, mass number, and then a charge if there is a charge on the particle. So the atomic number goes down the bottom. Like I said before, there's 3 protons in this nucleus, which means it's atomic number 3, which is how we ended up with the symbol lithium. And the atomic number goes down the bottom left. The mass number, which is made up of the protons plus the neutrons, we already said was 3 plus 4, which is 7, and the mass number goes up the top here. Okay. Sometimes you'll be given a nuclide notation and asked to work out how many neutrons are then in the atom. When this happens, all you have to do is do the top number minus the bottom number, because the atomic number is the number of protons, the mass number is the protons plus the neutrons. So if we take the number of protons away from the mass number, then we're just left with the number of neutrons. So it's quite handy to also have this little version of the equation written down somewhere in your notes as well, just as a reminder. So if you're trying to work out the number of neutrons, you just do the mass number, take away the atomic number, which is just the number of protons. Okay. The last thing when it comes to atomic structure is something called electron arrangement. You will find all the electron arrangements you need in the data booklet, but it essentially tells you how the electrons are arranged in these electron shells or energy levels. So if we look at this diagram of lithium here, we can see there's 2 electrons in this first energy level, so the ring that's closest to the nucleus, and then there's 1 in the second level. So as an electron arrangement, we would write that as 2, 1. Okay. So the electron arrangement tells you that there's 2 electrons in the first level, 1 electron in the second. When we look at the periodic table, if you look down the groups, you should notice, and the groups are columns, you should notice that every element in the same group has the same number of outer electrons, and that's actually what decides what group an element goes in. So if you discover a new element and it has 7 outer electrons, so 7 is the last number in its electron arrangement, so say it was like 2, 8, 18, 8, or 2, 8, 18, 8, 7 or something. Because 7 is the last number in the electron arrangement, that means it's got 7 outer electrons, so that means it should go into group 7. Okay. These are some things that SQL sometimes ask you. It's unlikely you'll be asked to draw the structure of a given atom. Most of the time you are just asked to interpret information from a picture, state things like the mass, the charge of each of the subatomic particles, use the atomic number to work out what element you actually have, and then also calculating the number of neutrons by taking the atomic number away from the mass number. But like I said, all the electron arrangements will be in the data booklet if you do need them. And as far as atomic structure is concerned, that's mostly it. You will then also learn about isotopes, but I've got a separate video on isotopes if you go and check that out. So yeah, I hope that helps you with your atomic structure knowledge. If you found it useful, please give it a like. Don't forget to subscribe, and I'll see you again soon. Sorry, one last thing I forgot to mention. So overall, atoms have no charge. So although they've got these charged subatomic particles within them, overall they don't have a charge if it is an atom. This is because atoms will always have the same number of positive protons as they do negative electrons. So notice here, this lithium's got 3 protons and 3 electrons. So the 3 positive protons will cancel out the charge of the 3 negative electrons, which means overall there is no charge. If we have an instance where we don't have the same number of protons and electrons, then it's not an atom anymore, it's then something called an ion. And if you want to learn more about ions, go and check out my other video in my National 5 Chemistry playlist on ions. When it comes to wording a question that's asking you why atoms are overall neutral, you need to make sure you state the charges of the subatomic particles that cause it to be overall neutral. So you must say positive protons and negative electrons, so the charges cancel out. If you were just to say they have the same number of protons and electrons, you would not get credit for that, because we can't assume that you know they're oppositely charged and therefore they cancel each other out. So make sure you're very clear in your answer that protons are positive, electrons are negative. Because there's the same number of them, the charges then cancel out. If you are presented with an atom, say for example oxygen, its atomic number 8, I think, yes, 8, atomic number 8, which means because it's atomic number 8, it will have 8 protons, and as an atom it will also have 8 electrons. You would need to know the mass number to be able to work out how many neutrons it had, but if you were required to do that, you would be given that information in the question.